Okay, so yeah, as Fabien said, I'll be talking to you about the work that I've done during my PhD, that has mostly focused on deception, mainly deceptive AI, and the work was done in collaboration with some people. Maybe you know some of them, maybe you don't. Here they are. So Raphael Bordini, Peter McBurney, Alison Panison, Simon Parsons, Yad Rahman, and Alex Rutherford. So we worked on different things about deception. We didn't work on like the entire thing. So not all of them worked on the entire thing, apart from me, Peter, and Simon, which have supervised me during the PhD. So here's the overview of what I'm going to be talking about. Now I'll give you a bit of a background, and then we'll talk about some theoretical aspects of deception and computational deception specifically. Then we're going to talk about how to engineer deceptive AI in multi-agent systems. And then we're going to see how deception evolves in multi-agent systems once we have engineered them. And then we'll draw some conclusions and probably discuss them if there are any questions. So yeah, part one. Yeah, so this work started from the question, can we use artificial agents to improve our understanding of deception? So can we use AI to better understand deception as a phenomenon? And from that question, we realized, okay, that's not, I mean, it's a very general question, but has some underlying assumptions, and that one of these underlying assumptions was that artificial agents can deceive. And then we decided, hold on, do we actually know if they can or not? So then we asked the second question, how may artificial agents deceive? And the work was mostly focused on the second question to answer the first one. And this resulted in, to the best of our knowledge, the first full computational treatment of deception in AI. And now I need to kind of like disclose and address the issue everyone's probably wondering about, is this thing ethical? Yeah, I mean, according to like some principles, it is. And one of the ways in which you can conclude it is ethical is by using reflective equilibrium. So using reflective equilibrium, you reflect on the fact that is this going to harm anyone? So the first principle, the non-maleficence principle. Well, not really, right? If you're studying, if you're using research and sandbox and simulations to study deception between artificial agents, so you're not really deceiving people, then it should be fine, as long as you're not deploying them in like, you know, open systems. Then there's the beneficence principle. Will this benefit? And the answer is yes. I mean, if we are able to understand how they deceive, we can actually, you know, get ready for it in the, I don't know, in the eventual case that they might be deployed in the world, right? And then there's the intellectual freedom principle. You know, we're researchers, we're curious, so we can do this based on the equilibrium. Then there is the openness principle. If we would have done this, you know, in a dark basement, creating, you know, deceptive AI and then launching it into the open world and not telling anyone about it, that would have been a bit dodgy. And then there's the honesty principle, which of course might seem paradoxical, but you know, the aim of research is to reach the truth. And in retrospect, okay, if you're able to understand deception, you might be able to detect deception. Therefore, you'll know that what is true and what is not. So yeah, I know this is a bit of philosophical method, but I think it's fine, at least to address the ethical issues, right? So having clarified that, we started looking at different definitions of deception, but what we mostly found was non-functional definitions. So the definitions about behavior or ways in which people could deceive in communication or not necessarily in communication. And for example, military deception, in which you manipulate the environment in such ways to distort the perception of individuals. But there was no functional definition. I mean, there were functional definitions, but no one in AI has treated them. So then we decided upon a functional one that we took from one of the theories that I'll be talking about next. So this resulted in the definition you're seeing: the deception as an intentional process of an agent to cause another agent, its target, to believe something is true that the deceiver believes is false or true, with the aim of achieving an ulterior goal or desire. So deception isn't just, for the sake of deception. It needs to lead up to something, whether that is malicious or beneficial. There might be ethical deception, but we can talk about that another time. Okay, again, why model deception and how? So again, the main point of this was to understand it, and mainly to understand what causes it and what prevents it from happening. And this, if this is called like the two phenomena are named event causation and event causation prevention. And Ferris, in his 1989 paper, so this guy Ferris, he's a historian. So he analyzes methodologies in historical analysis, but also in intelligence analysis. He looked at different cases of deception that have influenced historical outcomes, and he realized that historians and intelligence analysis analysts, when they reason about deception, they mainly reason about event causation and event causation prevention. Okay, fine. We know why we're modeling it, to understand this, but then how do we model it? And McBurney and others have suggested two approaches we can use to capture event causation and event causation prevention. And these two approaches are, one is from the formal logic approach, but with communicational semantics. So you represent the interactions between meanings of messages that are being exchanged between two agents, and how these meanings cause changes in the minds of other agents. And the other one was how these types of interactions scale up in large agent populations. So how they would affect social behavioral dynamics in large scale of multi-agent systems. So then we decided, okay, let's try this. Let's look first at, so let's split this in two levels of abstraction and look at the cognitive level, what's happening during communication, and then look at the social behavioral level. Fine, but where do we start? And then we're like, okay, we need to start somewhere, and it's better to actually ground your work in theory than do it ad hoc, right? So in order to do this, we started looking at the theory. And we looked at how humans deceive. And we found that there are two main approaches, one that's cue-based and one that is not necessarily cue-based. So I hope you can recognize Drake and what he means by the, yeah, okay. So there was this problem with cue-based approaches, especially in psychology and communication theory. First, there are lots of them, but there are also lots of scientific complaints about them, one of them being Offload Error, where due to bias, so Offload Error happens when someone who wants to detect deception is too suspicious and assigns motives that aren't there, or there might be there, but they're assigned by that person because that person only looks at the evidence that confirms the hypothesis that deception is there. And then you make, you basically are not a good detector of deception. That's what happens. But there are these non-Q-based theories that don't look at deception just based on what can be observed, but also take into account what cannot be observed, and take into account different types of models of human interaction. So we try to ground our approaches in these three theories. So information manipulation theory looks at how our minds reconstruct meaning during communicative interactions, and talks about how we select specific type of information that we want to communicate in order to cause a certain interpretation in the mind of the other. And apparently this theory arose from Steve McCornack, the proponent of the theory, looked at, okay, what's going on in AI, and was a bit familiar with good old-fashioned AI, and tried to reconstruct this with speech act theory. And then there is truth default theory, which doesn't only look at how we select information to communicate to cause others to have false beliefs, but also looks at the context in which this happens, in the sense that we don't just, try to deceive or not try to deceive just because. We do it when we have something to gain, or when there is an opportunity, or and we're successful because most people are in this truth default state in which they don't expect people to lie to them. And that's because of evolutionary reasons, Levine argues. And then there's the big overarching theory called interpersonal deception theory, which is a bit Q-based, but the good thing about it is that takes kind of like a multi-agent interaction approach to looking at deception. So there's like this ongoing interplay in different social contexts with different parameters and factors at play when deceptive messages and detection of deceptive messages are being transmitted between individuals. So yeah, that's it. We mainly took these three and tried to integrate them in our approach to study deception. But then there was the problem, okay, fine, we have the theory, how can we define our deception? How do we look at it? What's the framework? What do we need to consider? So looking at the theories, reviewing them, we realized, okay, first you need some sort of intentionality. So the agents need to intend to deceive or not to deceive or tell the truth or to intend something. So there needs to be intention there. There need to be some sort of social ability. So artificial agents need to be able to interact socially. It needs to happen in a multi-agent system. It can't just happen. I mean, there's the case of self-deception, but that's it's a bit weird. We can talk about that if you want. There is actually nice paper about it in epistemic logic. But it needs to happen for a reason in a system of multiple agents, and it needs to happen between at least two agents. And then there's the artificial theory of mind, that in order to deceive, the agents need to have a model of their target. You can't think, you can't deliberate, you can't reason about causing someone else to have a false belief without having a model of that individual's mind. Then there's the causality of communication. So what you're saying, what you're communicating needs to actually cause changes in the world. In this case, changes in the minds of the others. And then there's some sort of contextual knowledge. You need to take into account that when you're communicating something, you communicate it in a context, and different contexts make different individuals infer different things. So when you want to deceive, you need to take that into account, what might be inferred in different contexts. And then from that, we created a taxonomy of different types of deception. Out of this taxonomy, we mainly looked at one-way deception and distributed deception type 3. We thought these were the, well, not the basics. Type 3 was the most complex and most interesting out of all of them, and type 1, well, you need to start from somewhere, so you need to have the foundations, and then you go to do the really complex stuff, so we skipped the part in the middle. I mean, we didn't skip it, but we didn't really have time to address all of them, which I do want to do in the future. Okay, enough about theory. I'll just now go through the overall contributions of what happened. So first, how do we engineer them? What do we do? So we need to engineer agents that are able to do complex reasoning in order to communicate. And we did this using BDI models, dynamic epistemic logic models, that we translated in the JSON agent-oriented programming languages. So we took these models, we thought about the reasoning, the inference processes, and then, okay, let's give a step-by-step description of how to do it in an agent-oriented programming language, right? And this is based on like speech act theory, that theory of mind, and we integrated these factors of deception from interpersonal deception theory. So this is the overall what we did. But before we could go to deception, we needed to address a big gap in this entire process, namely theory of mind. Deception cannot happen without it, at least it's not meaningful without it. So first we needed to engineer agents that could reason about other agents' minds in different contexts, about different things, at different levels of knowledge. So what we did, we defined operational semantics to do this, because we wanted to track every step of the reasoning process and every step of the communication between two or more agents. We didn't just want to, engineer a black box. We wanted to be able to explain, right? Event causation prevention, we wanted to know what's happening, why, or why it didn't happen, or why it did happen, and under which circumstances did it happen, namely deception or no deception, depending on the situation. So, yeah, we needed to do theory of mind. So first to address this, we did this by defining those operational semantics, and then we studied how agents reach, for example, shared beliefs. A shared belief means I know that you know that I know that you know something. So this is a shared belief. It can happen at different levels, and it can happen quicker or slower, depends on the trust and the uncertainty of the communication channel, and all sorts of things. But also these things happen in different contexts. Agents can reason about hypothetical contexts in the sense that, oh, if I were in a different agent organization, or if I were in a different social context, what would this agent infer if I would say A or B or C or not A or not B or not C? So in order to, like, if you guys are interested in the basis of this, you can look at these two papers that we worked on. Okay, fine. We had this theory of mind thing. Agents were able to reason about minds of other agents in communication. But then, okay, how do you tell apart different types of liars? So this was a preliminary work, what I'm showing you now. So this was we mainly looked at, okay, we need to separate deception from lying and bullshitting, because they're different things. And the main difference between these three is that lying is a statement that doesn't, like, you don't need a theory of mind there. You just state what you know is not true. Bullshit, on the other hand, you state something and you're ignorant about it. Like, you don't know if it's true or not, you just state it for different reasons. I don't know. But deception is here is deception through lying, but in general, deception is about causing false beliefs with an ulterior goal. So we made this distinction. But then we were like, okay, fine, but deception doesn't just happen through lying, it can also happen through different things. And one of the theories, information manipulation theory 2, actually says that, you know, when you deceive, there's actually no distinction in terms of cognitive load, whether you're telling the truth or you're lying. You're still causing a false belief, but it doesn't matter. Like, what you're interested in is causing a false belief, but it doesn't really matter if you're telling the truth or not. And that's actually accurate, because we found out that it all depends. It depends on multiple things, like the theory of mind, like the confidence you have in the theory of mind of the other. But also it depends on your communicative skills. So what we did here, we took the same approach with operational semantics and those BDI models, and plugged in different factors, uncertainty factors that could influence these things. And we found out something interesting about deception with BDI agents, is that unintentional deception might happen if some agents are too, like if the receiver agent or the target agent is too skeptical, and if the deceiver is not very good at estimating its success at deception. So even if the deceiver decides, okay, fine, I'm not going to lie, I'm going to tell the truth, the other agent might be too skeptical and infer that the opposite, and might reach a false belief, a false conclusion that was the deceiver's goal in the first place, but the deceiver wasn't really good at estimating different factors, so, and didn't have an accurate theory of mind, so deception happened. But the thing is, the deceiver doesn't know it happened. It happened, and the skeptical agent actually influenced, didn't want to be deceived, but actually ended up being deceived. So there are some scenarios in which this happens. And yes, we did call the deceiver Donald, if that's your main question. So basically, we learned these things, that we can actually represent deceptive communication, and we can represent what happens in artificial agents' minds, what happens inside their minds when they're deceived or when they're trying to deceive. We can engineer them in an explainable manner, and we can explain event causation and event causation prevention, but also what happens inside their tiny little artificial brains. We've concluded that theory of mind is crucial for this, and that unintentional deception might happen. And it's actually a property of BDI, how intention is defined in the BDI model, because they're making the distinction. So in BDI, you have the distinction between desire and intention. And this is why unintentional deception happens. So deception is desired, but it's not intended, something like that. Okay. That was intense. Okay, but it's not over yet. So now in this part is, in part 3, we're assuming, okay, we've done this, we've engineered them, but what if we threw them out in the wild? What if the state of AI would become so that we can actually engineer them, give them this ability to read minds, extract theory of mind from humans and from other agents, and really be able to deploy these types of agents? What would happen? And this is more of a, not a standard computer science approach, it's more of a machine behavior approach. So how do we study deceptive machines in the wild? And one of the things that can happen is that, well, in first instance, probably you won't design robots, or maybe you would design robots, but the first thing we thought about is, okay, if hypothetically, if they are to be deployed, they could be deployed on the internet, right? But it's not just, you know, deep fakes, GPT. This, we're talking about here about agents with intentions. They form their own plans, goals, and reasons to deceive. They extract the theory of mind of their targets, and then they start deceiving for different economical, political, sociological reasons. And what we're actually studying here is whether, you know, these agents would destabilize cooperation in different systems, or would all agents start to free ride and they would destabilize different political, social, digital or not digital systems, or hybrid systems. We're talking here about hybrid societies. And we applied some concepts like public goods games of knowledge sharing, evolutionary mechanism design, and the tragedy of the digital commons. So we wanted to know what happens in time, right? Over time, in different periods, and if these deceptive agents would be able to destabilize cooperation over shorter or longer periods of time. And because we're employing like this evolutionary mechanism, we also have what's called social learning in multi-agent systems, in the sense that what agents do, they're put together, they're made to play this public goods game, and then they start imitating, adopting different strategies. So imagine that agents are not, you know, intrinsically deceptive, but they have the capability to deceive, but they're also able to decide, oh, I'm not going to deceive, or I'm going to defect, or I'm simply not going to participate in online debates. Fine, so they can do these things, but they should be able to pick these strategies. And this social learning kind of determines how they pick them. So if it's strong, they will always pick the strategy that gives them the highest payoff. If it's weak, maybe they don't. So this is kind of like the mechanism that drives the evolution. And I also talked about this tragedy of the digital commons. So the main purpose of this type of method is to see to study the behavior of the machines in such a way as to see whether this behavior will lead to a tragedy. So in this, I call it the TDC. So the TDC is all about public goods. So when multiple agents need to share a resource in order to sustain their lives, let's say. But something happens with public goods. Defectors can happen in the standard public goods game, and which don't contribute to the public good. So for example, you know, someone, okay, probably this is a bit controversial. Let's say you're, you know, you're traveling with 6 or 10 or 60 transatlantic, transcontinental flights per year, but you've never given a damn about, you know, the environment, or to contribute to sustaining the environment. This is mainly what's happening. But here we're talking about the specific public good, named information or knowledge. And this happens in the digital sphere, or the infosphere, as Greco and Floridi call it. And what happens with knowledge or information in this infosphere is it can be polluted and can be exploited. And it can be polluted or exploited by either humans or artificial agents. So basically we wanted to know, okay, does deception lead to a tragedy, or it doesn't? Who knows? But like, we didn't know, so we want to see how, under which conditions. But the thing is that some studies have looked at this. I mean, not at deception, they've looked at how to govern public goods. Because the public good can be regulated, otherwise it would be free for all and everyone would defect and the public good would be destroyed. And what they found out was that peer punishment, which is similar to decentralized Western democratic forms of government, is actually better, well, actually manages to establish or reestablish cooperation. Whereas centralized forms of government fail to do this unless there's some sort of second order pull punishment, but we're not going to talk about that because we're not interested and it doesn't really contextualize in this work. And there's been another paper that showed that actually if you have agents that start to corrupt agents to use the public good, this actually drives the emergence of decentralized Western democratic forms of government, which was cool. But we weren't really interested in this, but we were interested in starting with this type of baseline. We wanted to reproduce this public goods game for social learning. So our question is, okay, what happens to cooperation? We know it's established, we wanted to reproduce it, but what happens if we introduce deceivers? But, you know, we also wanted to know about how to govern societies in which deceivers are present. Therefore, we actually ended up with 6 public goods games, not one, because we wanted actually, okay, to find a solution for it. Because this is what happens if you introduce deceivers. So this deceivers destabilize cooperation. So here what you're seeing is the long-run average frequency for a public goods game that has pull punishers, peer punishers, cooperators, defectors, and loners. So loners are people that just like simply don't use the public good, but don't actually contribute to it. So they decide not to participate. So the previous one, PGG1, so this one where there are no deceivers, is everyone's supposed to be, so you would have 90% of distinct PEP. These are peer punishers. So decentralized forms of government or people that establish a decentralized form of government. Okay, cool or not cool. Deception actually destabilizes this. But what happens if we actually start interrogating them, start, you know, putting out their forms of regulation and punishment for deception, not just punishment for defection. So the first one was, okay, we're going to combine a centralized government that works separately from these investigators in PGG3. Then we decided, okay, we got to try with a decentralized government that works separately from investigators. And then, okay, centralized government with investigators. And, well, it didn't end up well. So every time with all of these combinations, deceivers and defectors managed to free ride, and cooperation wasn't really reestablished, or if it was reestablished for very short periods of time. So it was mostly chaos. But what if a decentralized form of government that was, you know, successful previously worked with these interrogators? So imagine this Batman scene in which you have, you know, 2 government officials from different institutions working with an interrogator, in that sense, Batman, against the Joker, right? That's the deceiver and the defector and wants to create chaos. Well, basically, they managed to do it, just like in the movie. They managed to reestablish cooperation in the sense that they're very successful. They actually drive cooperation. So this type of regulation or this type of strategy manages to drive cooperation. Okay, so this is the summary for the 2 sets of experiments, one with weak social learning and the other one with strong social learning. I forgot to mention that they only managed to establish cooperation if social learning is strong. Otherwise, it doesn't really happen. They do perform better than other types of regulatory systems or interrogation systems, but still not good enough to reestablish cooperation over long periods of time. So from this, we basically learned different things. Deception does indeed break cooperation. There are different factors, that social cognitive, such as social learning, that determines whether, also it determines whether deception is successful or not, right? But also it determines whether a decentralized form of government with case-by-case type of interrogation strategy manages to reestablish cooperation. And we've learned that, okay, in most of the cases that we've studied, the tragedy of digital commons, well, unfortunately it happens, but it can indeed be avoided. And we need to be wary of centralized system of government that are susceptible to deception, more than decentralized ones, especially when you have interrogation systems. And you can make different sorts of analogies. Think about forms of like governments or forms of government systems in which journalists, the interrogators, the independent investigative journalists are able to work with the government and inform them, and the government actually acts upon the system, acts upon whether deception is present or not in the system. Okay, so this was mainly about the evolution part, and now in summary, well, all the things I've told you about was how we grounded this computational theory of deception, how we can model the deceptive AI at different levels of abstraction. These were two different levels of abstraction that together kind of like explain or give you a story about deceptive AI. First, how do you create it? And if you create it and if you deploy it, what would happen with society, with hybrid societies in which deceptive AI is present? Yeah, and another thing that I proposed in the thesis was that maybe in order to actually understand deception or to understand it better and to act upon it in the real world, probably we need a multi-agent systems framework for deception analysis. So currently, methodologies in intelligence analysis that deal with deception are either burdensome, like they have lots of cognitive overhead, so it's very difficult for analysts to perform them, or they're very shaky sometimes. So a multi-agent systems framework would actually help you distinguish different levels of abstraction, would help automate conductive reasoning, for example, or aid in performing conductive reasoning. You could see how different sources of information and messages cause different changes in the minds of different organizations. And also you can, like, if you have multiple agents, you can scale this up. You can test different scenarios. So basically, this is kind of like this would be a dream come true from this entire research. Again, thank you for listening to me. And are there any questions? I'm happy to answer any questions. So